Hi, today let's discuss how to find the area of a rectangle with side lengths 2/3 and 5/2. Let's quickly review what we discussed in the last video. In a previous video, we discussed how to find the area of a rectangle with side lengths 1/3 and 1/2. And we used this picture. We started with a unit square, and inside the unit square we were able to construct for ourselves a rectangle with those side lengths. And using this argument, we said that the area of such a rectangle is 1/6. We also commented that 1/3 times 1/2 is in fact 1/6, and hence that it's easy to, for remembering purposes, it's easy to say that the area of a rectangle with side lengths 1/3 and 1/2 is in fact 1/3 times 1/2, because it does end up giving us the answer of 1/6. Now let's go back to the original problem we wanted to discuss in this video. So back to our original problem. Here we proceed as follows. We try to build on what we just learned. We know how to find the area of a rectangle whose side lengths are unit fractions. That's what we already discussed. So here what we have is side lengths that are not unit fractions. So this is how we proceed. We first construct a rectangle with side lengths 1/3 and 1/2. And if you look at this picture, this piece is of length 1 and this piece is of length 1. So we use that as a guideline to mark off 1/2 here and mark thirds off on this segment of length 1. And now if I look at this rectangle's side lengths are 1/3 and 1/2. There it is. Let me shade it. We do know how to find the area of this rectangle from our previous work. So let me write that here. This guy's area is 1/3 times 1/2, which we can also write as 1/3 times 2. So keep that in mind. Now this is how we proceed. I would like to build a rectangle whose side lengths are 2/3 and 5/2. I use this as a building block and I start putting together rectangles of this size to create a big rectangle as follows. The side lengths needs to be 2/3. This is 1/3, so this is 2/3. So there it is. And how far do I go? Well, this side needs to be 5/2. This is 1/2, 2/2, 3/2, 4/2, 5/2 would be this part. So I proceed like this, connect. Now I'm going to make some marks out here. So I put together several of these rectangles to build my big rectangle. How many of them? Well, it's 2 rows and 5 columns. So that is 2 times 5 number of rectangles, smaller rectangles. And notice all these rectangles are congruent, even though it doesn't look like that in my picture. They are congruent. So once we know the area of this rectangle is 1/3 times 2, we also know the area of each of these 2 times 5, each of these 10 rectangles is also 1/3 times 2. Now it's just a matter of writing down what is the total area then, or in other words, the area of this rectangle. I'll write it as big rectangle. What is that? It is really 2 times 5 copies of the area of a typical rectangle, which is 1/3 times 2. So what do we get then? We get 2 times 5/3 times 2. Now notice, this is also, we can calculate this and we can come up with an answer. In fact, if you use the cancellation law of fractions, the 2's cancel out and you get an answer of 5/3. But I also want to point out that this this expression 2 times 5/3 times 2, it's convenient also for memory reasons to think of it as 2/3 times 5/2, because in fact 2/3 times 5/2 is 2 times 5/3 times 2. So our conclusion is the area of a rectangle whose side lengths are 2/3 and 5/2 is really 2/3 times 5/2. And then you can do your calculations and get your answer of 5/3. So let's summarize this discussion using letters. So even though I used numbers 2/3 and 5/2 as the side lengths of a rectangle, this argument holds true for regardless of which fractions you choose for your side lengths of a rectangle. So let's summarize that into a formula right now. So here's the quick summary. Suppose A, B, C, D are whole numbers and B is not equal to 0, D is not equal to 0. Area of a rectangle whose side lengths are A/B and C/D is given by this formula. So here's the picture. We have a rectangle. One side length is A/B, the other side length is C/D. By our discussion, area equals A/B times C/D square units. And of course, from our product formula, we recognize that this is really same as A times C over B times D. So be sure to remember this formula and also all the reasoning that we did using specific examples. Thank you.